Okay, sir, you can start. Session is
Oh,
yours.
okay, thank you, sir. Very good afternoon to one and all. Now we completed. Hello. Now we are entering sixth day AACT Atal Online FDP in the title of Next Generation Green Energy Powered Electric Vehicle and Renewable Energy Integration using Solar Microgrids. So now we are going to see the title of session number 11, Optical Allocation of Energy Sources in Renewable Energy Scenarios. In the expert session of Dr. Chandrasekhar Garu, Professor, Department of EEE, Mallaradi Engineering College. Now we will read out the bibliography of Chandrasekhar Sir Garu. Sir has received PhD from JNTU Anantapuram and Sir completed MTech Powertronics from Patna Raja Reddy, Rajendra Reddy Memorial Engineering College, Rangareddy, as well as BTech completed from VNR Vignan Jyoti Institute of Engineering and Technology, Hyderabad. Presently, Sir is working as an associate professor at Mallaradi Engineering College. Now, I am handovering the sessions to Rajan Chandrasekhar Garu. Please take the sessions.
Okay, thank you, sir. Okay, today we are discussing about a topic. Yeah. I'm sharing my screen. Is my screen is visible, sir?
Yes, sir.
Yeah.
Make it full screen. Yeah,
Is it visible?
Yes, sir. Please, sir. Visible. Go ahead.
Yeah. So now my topic is today for session, optimal allocation of energy sources in renewable energy scenario. The use of renewable energy sources in the power grid has increased in last decade. So despite the environmental benefits, the installation of a renewable energy sources in the electricity distribution networks is challenging and changing from day to day. So it is a challenging technically, and it is also changing the allocation of a renewable energy sources. So, before starting my session, here I want to quote one word. The time is running out soon. There will be nothing left to burn on earth by earth itself. So to produce a electrical energy, the existing sources which are there in geographical conditions, we are burning the coal, which produces a pollution, and we are burning the uranium materials to get the energy from the nuclear energy sources. So from day to day, with this, the earth burn itself. That means while earth is burning, it's very difficult to either human beings or atmosphere conditions or every condition, it is difficult to live on the earth. So here, the natural sources are existing on the earth itself only. Just like a wind and solar. So here, our intention is we are going to be producing electricity by reallocation of the variable energy sources together. So in development manner, the development context, the developed India emits double the allowable carbon emissions set to prevent climate changes. Due to the in the name of a development or in the name of a developing India, we are producing 80% of total population in rural areas, and we emits 1/4 of carbon emitted by the developed India. Due to this carbon and emissions, our urban populations increases, and it is irreversible stress is put on urban infrastructure heavily by burning of the coal or fossil fuel. So all these are the dependents. So due to this one, whenever generation of energy is energy generation cost is increases, once energy generation cost is increases for the utilization purpose or for the transmission or distribution, in every aspect, the cost is also going to be increased. High cost of irrigation. For irrigation purpose, the cost is increases. Due to high cost of irrigation, the lack of productivity is there. Once lack of productivity is there, and it to reduce the profitability also. So lack of power for local value addition, absence of enterprise and livelihood opportunities. Once there is no sufficient power generation, so the absence of enterprises is also exists. Primitive cooking and lighting solution. The negative health effects, lack of productivity time and inefficient resource. So we know already existing few renewable energy sources. Just I want to give their names, and here I don't want to discuss anything because all that you know. The basic renewable energy sources which are producing electricity up to now existing: solar, wind energy, ocean thermal energy, geothermal, and biomass or biogas. These are the existing renewable energy sources. So the solar energy is the energy which receives from the sun radiations, primarily visible light and other forms of electromagnetic radiation. The solar energy converted into electrical energy by using solar plates, solar cooker, solar heater, and solar coil. These are the few examples. And wind energy. The wind power is a good renewable, clean and free source of energy for power production. Reduce dependence on fossil fuels, including imported oils, or reduce emissions of greenhouse gas and other pollutants. One major concern is the noise be improved. And the ocean energy, the ocean covers 75% of the world surface. It is the largest renewable energy source available to contribute to the security of the energy supply, to reduce greenhouse gases emission. So it is a ocean energy and biomass energies. So here renewables provide a new jobs, and our country will be less dependent on other for fuel and environmental reasons also. Renewable will decrease air pollution and greenhouse gas emissions. Sir, are you getting my voice?
Please proceed. We are hearing, sir.
Yeah. Suddenly some power disturbance is occurred. Okay. So why we need alternative energy sources? The important thing is economical reason. Because of fuel cost is increases, and renewable provides a new job opportunities also, and our country will be less dependent on other for fuel. That we know naturally what happens with Iran countries and Iraq countries when these American peoples are depends on the for fuels. So that everyone we know completely we depend on fuel on that are the Arabic countries. So in environmental reasons, renewable will decrease air pollution and greenhouse gas emissions. So fossil fuels currently supply 80% of the world's energy, but renewable energy use is rapidly growing. So due to the impact of climate change, increasing at an alarming rate, sustainability has become a necessary action. With that being said, the internet is flooded with the quotes on sustainable energy that emphasize the need using cleaner and greener energy. Adapting sustainable energy practices can help us get a step closer to building a renewable for future. So, what is the benefits with the renewable energies and what are the advantages? Once you got a solar panel on a roof of our house, once we got a solar panel roof of our institution or our college or our house or where we are, the energy is free for us. Means we are generating energy. We are generating energy. So we can convert our entire electricity grid to green and renewable energy. So which cost of living goes down. We know once electricity bills cost is increases, how much political imbalance is happens. If we increase the 1 unit of a charge for consumers or for industry or for any other persons, means the increasing of charges on electricity, we know how it leads to what are the effects on society. Instead of that one, if we build our own plants, means solar is there. If you the solar panels, if you place on roof of our house, so the energy is free. If we generate more power with our house or with our solar panel, that we can send back to the grid also, and that storage systems is also there. A strong renewable energy industry is a good for our environment and our economy, because for the all with the polluted grids, we know how much pollution is there with the thermal power plants, and even how much losses are there per generation, and how much time being is also very less to build a thermal power plants or nuclear power plants as compared with the solar. And there is an argument need to stop subsidizing the fossil fuel industry, dramatically reduce wasted energy, and significantly shift our power supplies from oil, coal, and natural gas to wind, solar, geothermal, and other renewable energy sources. To truly transform our economy, because we can say that depends on how much electricity you are consuming, or depends on how much power consumed by one industry, or how much power is consumed by one household, or how much electricity you are used by our house meters or industry, that we can say either we developed or we are under developing or developed. So that truly transforms our economy, protect our security, and save our planet from the ravages of climate change, we need to ultimately make clean and renewable energy that profitable kind of energy. The use of solar energy has not been opened up because the oil industry does not own the sun. Clearly, we need more incentives to quickly increase the use of a wind and solar power. They will cut costs, increase our energy independence and our national security, and reduce the consequence of a global warming. So daily on the surface of Earth, the temperature is increases generally. So before in summer we are getting a 47 degrees at Ramagundam or 48 degrees at in Kottagudem, in that area. It is a very hot temperature. And from last 2 years back, at some time we reached it is 52 degrees also. Means the surface is getting heated. So the surface getting warming. So with that heat also, we can, so means if you install a solar plants, so we can get more electricity. There can be no sustainable development without sustainable energy development. That means the nation, we need to produce more energy in the form of a clean and green. Energy is essential for development, and sustainable energy essential for sustainable development. It is a time for sustainable energy policy which puts consumers, the environment, human health, and peace first. Sustainable energy gives a plus food security plus healthy environment. All this gives the full employment and better future. That means everything depends on either industry or any work, either factory or road transport system or rail transport system or auto transport system or anything. Now it's completely depends on the energy. So that energy to be clean and green and safety as well as securely. So the increasing dependency and consumption of a non-renewable energies have resulted in global energy crisis. In such a scenario where numerous countries are undergoing shortages in power and energy production as well as consumption, switching to renewable sources of energy can seem like a wiser option. In fact, several renewable leaders worldwide are preaching how a transition in renewable sources of energy can also help reduce the impacts of global warming. So everything we make pollute. Everything we make pollute. The most responsible thing we can do is to make each product as well as we know how so it lasts as long as possible. Generally, the oil-based society depends on non-renewable energy sources. Non-renewable energy sources. It requires a probing into vast reaches of pristine land. So we must all move shoulder to shoulder. So it is our responsibility to build a renewable energy sources. So to produce a clean energy. We know we will run out of a dead dinosaurs to mine for fuel. How to use sustainable energy eventually. So why not we go for renewable and avoid increasing risk of climate? Betting that science is wrong and oil companies are right is the dumbest experiment in history by far. So how can we make a difference? We hope they just need to begin. We need to start the integration of the together. It to be operated combinedly. If you are having a difficulty gathering confidence, here are so the here the allocation optimal means we need to choose the best method, or we need to choose the best one for allocation of energy sources. So here the main problem is for planning and optimal operation of renewable energy sources. For optimal, the problem is for planning and optimal operation of a renewable energy sources. Here, optimal allocation of energy sources in a renewable energy scenario, which refers to determining the most efficient and cost-effective combination of different renewable energy sources. This process involves considering various factors. So once we are combining the different plants together and choosing a best option, and we are reallocating, or we are going with the optimal allocation means, for that process, we do be consider various factors. The important factors is one is availability of resources. What are the resources are there, and technological capabilities. And another thing is geographical constraints are very important. For geographical constraints, generally in one particular place wind plants are familiar, in one particular place solar plants are familiar. And now we want to operate together this one. So when we are integrating wind as well as solar together, So the geographical constraints also important, and cost and the environmental impact. And the other factor is environmental impact. So reallocation of a renewable energy sources refers to process of adjusting distribution of different renewable energy sources, solar, wind, hydro, and geothermal power across a region are grid based on factors like geographical availability, energy demand patterns, and technological advancements to optimize energy production and efficiency. So the key factors in reallocation of sources, in reallocation of renewable energy sources, optimizing resource utilization. The one of the key factor is optimizing resource utilization. By analyzing the potential of a different renewable sources in different locations, the allocation can be adjusted to maximize the energy generation from the most suitable sources. Okay, we are getting with the renewable because at the oceans, we are getting a ocean energy, and at the hilly areas, that wind energy is familiar, and generally the solar is there. Now we want to combinedly operate all these things. That means we need to choose resource utilization, the best utilization we need to choose, because all these grids, either solar plant or wind and hydro and geothermal, all these power plants are working with their intermittent behavior, because their inputs, so the solar energy is not at all constant. Of course, we are getting a solar energy, but it is for 24 hours, it is not the same. And the motion of wind is also alternating. The motion of wind is also not at all constant. And for the geothermal, the heat ratio, the heat and coolant ratio of the water under the earth, so it is also changing. Once we are combined operating with all this, we take care about the outputs and the constant generation of energy, the constant output power. And another factor is grid stability. Reallocation can help to balance the grid by considering the intermediate nature of some renewable energy sources. Because if we completely depends on a solar, in winter it is problem to supply the power to consumers or to handle the load. At that time, my wind power plant takes the place. So here we are integrating them with more stable sources like hydropower, because hydro is a source of power. Hydro is we are not only depends on a wind, or we are not only depends on a solar. It is integrating with all renewable energy sources together. And with this, another benefit we are getting is cost effectiveness. Cost effectiveness. The economic considerations are very important to plan the power network and operate the power system networks. The economic considerations are always important. So, by strategically placing renewable energy sources projects where they are most efficient, the overall cost of generating renewable energy can be reduced. By commonly operating these all plants together, by choosing a correct place and by correctly integrating methods, the overall cost of generating renewable energy can be reduced. And here, the governments, either state governments or central governments, are encouraging. They are encouraging industrialists. They are encouraging even individually, and they are encouraging even farmers also. So the government brought a number of policies. The government policies and regulations play a major role in guiding the reallocation of a renewable energy sources by setting targets for different renewable energy types. And the energy here, the reallocation of renewable energy sources, it can be conducted through a energy assessments also. We need to make a list where how much facilities are available to us and obtain full year data of electrical bills. It to be compared with the existing plants and it to be calculated for next few years. And the factors which are influencing a reallocation, geographical conditions. Yeah, just now I discussed this one because all renewable energy plants are intermittent in nature because wind speed and solar radiation. The wind speed is not at all constant speed and solar radiation is also not at all constant. These are timely changing. And water availability and geothermal potential vary across the locations, which is dictating the best renewable sources for each area. Energy demand patterns, the timing and location of a peak electricity demand influence the allocation of a renewable sources to ensure sufficient supply when needed. And technological advancements, improvements in energy storage technologies can enable better integration of a variable energy sources. Means what is energy storage technologies? Now, whenever I am generating a electricity, either it is a solar or wind, generation is increases, or any wind generation is increases. Now we are connecting that grid network with along batteries, battery energy storage systems. So battery energy storage systems means whenever the generation is huge amount of generation, means high amount of generation, more than the requirement. So the batteries also there. And whenever the energy is less and it is unable to be satisfy the load conditions, and we can get power back from our battery. So that integration means battery storage systems are integrating with the renewable energy sources, and which can be calculated for daily and weekly and monthly average also. And existing power lines and transmission capabilities can limit the potential for certain renewable energy sources in specific areas. And few reallocation systems are there. They are the hybrid renewable energy systems. One is, and the other one is a distributed generation, and another one green energy corridors. And green energy corridors, in our country, few states are selected. It depends on their geographical conditions. Green energy corridors are identified by the central government of here. The projects are there. From the central government of India, it aimed to connect the renewable energy sources like solar and wind to the national power grid. These green energy corridors are brought in as commissioned in 2012 September. Due to the green energy corridors, to improve the efficiency of the power system, to enhance the generation and supply and distribution of the electricity. The Power Grid Corporation of India Limited identified few states: Tamil Nadu, Rajasthan, Karnataka, AP, Maharashtra, Gujarat, and Himachal Pradesh and Madhya Pradesh are identified as a green energy corridors. to develop dedicated transmission infrastructure and to facilitate the integration of large-scale renewable energy projects in various regions with high capacity and high potential. The resource availability and location. The other factors which depends on resources availability and location. Geographic factors. The renewable energy sources have site-specific characters. For example, solar energy is more effective in regions with high sun exposure. While wind energy requires areas with consistent wind patterns. Hydropower depends on the availability of a suitable rivers and water bodies. So, resource variability. The availability of a renewable sources can be intermittent because we know that that conditions are not at all constant. So, to understand the patterns of availability and demand is crucial for proper allocation. Depends on the load demands. We know peak demand and off-peak demand and load profiles. The energy sources have to be operated to reach the demand. So every energy sources have different with their capacity. Means each sources are operating with the different capacity factors and availability. Wind, solar, both are intermittent and their contribution might not always align with the peak demand. So to overcome this one, in between these two plants, we are integrating energy storage systems, that is batteries. So this generally we call a grid balancing mechanisms. So which you need with renewable energy sources. The grid balancing mechanisms might be needed to reach or to supply the different hours of power, either peak power or peak demand or off peak time, and season variability. So we know solar energy might perform well in summer, while wind energy may be more productive in winter. But as a suppliers of electricity, so it is our responsibility to supply the power with effective power and efficient power to the consumers. So this requires a mix of energy sources to balance out to seasonal variations. So and technically, few factors need to be considered for these energy sources. One is capacity factor. The capacity factor measures how often compared to the geothermal and hydroelectric power, and efficiency and cost. Some energy technologies might be cheaper or more efficient in certain regions. For example, geothermal is a good option where geothermal reservoirs exist, but it may not be feasible somewhere. And this energy storage and grid integration. Intermittent renewable energy sources, the solar and wind may require an energy storage system. The energy storage systems is with the batteries and pumped hydro storage system to provide a continuous power supply when production is low. When production is low, the production units that use renewable energy sources are usually of a limited size. So in order to integrate more smaller units into the power grid, we know that we call a distributed generation or DGs or microgrids. Due to the variable intensity of primary energy from the renewable sources, the implementation of a battery storage systems, the implementation of a battery energy storage systems is also increasing present in renewable energy scenario. So the use of DG and battery energy storage systems together, the use of DG and battery energy storage systems together, here these two units are combinedly we are using. It aims to exploit the available intensity of the energy sources as much as possible. But while using maximum availability energy from DC sources is always optimal from the point of power and energy losses in the power distribution system. And the other one is grid flexibility. The existing grid infrastructure must be able to be handle distributed generation and integrating renewable energy efficiently. Technologies like smart grid. We know about a smart grid. It is completely the existing grid only, but the existing grid is replaced with some communication networks, and the existing meters are replaced with the smart meters, and it is a two-way communication system. The smart grid is two-way communication system. So already in our country, the government is planned to install the smart meters. They identified the few smart grid projects, and they're working under, they're replacing the existing meters with the smart meters. And demand side management and flexible generation plants, natural gas peaking plants can help manage the variability of renewable energy sources. And capital and operational cost, economic consideration. What are the various economical factors with grid reallocation? Capital and operational cost. The initial investment and maintenance and operational cost of a renewable energy systems vary. Wind farms and solar PV systems often have high upfront costs while operational costs are low. And subsidies and incentives. The government making a policy. The governments are making policies and they are giving some subsidies and incentives to start the solar projects to the industrialists and for the farmers also. So various considerations are there for their electrical service, for installation requirement and training. And levelized cost of energy. And this is the cost of producing 1 unit of energy over the lifetime of the project. Factoring in installation, operation, and maintenance costs. Helps this levelized cost of energy helps in different energy scenarios. Generally, here the government makes a few policies, production linked incentives. The schemes are there, various schemes are there. And in my presentation, I given few schemes which are given by the central government of India. I mentioned the few schemes also. So one among is production linked incentives. It is financial incentive scheme in India that aims to boost the domestic manufacturing and attract large investments. The production linked incentive scheme for high efficiency solar PV modules is a government program to promote the manufacturing of solar PV modules in India and to reduce the Indians' dependence on other countries to import solar panels and to increase its manufacturing capability. It builds a manufacturing capacity for a high efficiency solar PV modules and bring cutting edge technology to India for manufacturing of high efficiency modules. And environmental and social factors, land use and impact. Some renewable sources, example, wind farms and hydropower, may require a large land areas, which can impact ecosystems or land use. Solar farms can be installed on rooftops as part of dual use agriculture systems to minimize the land use conflicts. And community acceptance. The location of energy generation facilities might influence community acceptance. Offshore wind farms, for instance, can be less intrusive to communities compared to onshore projects. For optimization models and the techniques, the optimal allocation of a renewable energy source is often determined through the optimization models. There are few various models are there: mixed integer linear programming and dynamic programming and mega-heuristic algorithms and particle swarm optimizations and fuzzy logics, and you can use various techniques. Supply demand balance, resource cost, and other factors, environmental constraints, technological limitations, transmission cost, and grid integration. So with this reallocation of systems, we are to be operated with the hybrid. We are made with the hybrid systems. The hybrid renewable systems combining different renewable sources can help balance their intermittency. And cross-border cooperation. Sharing renewable energy resources between neighboring regions or countries can optimize resource use and improve grid stability. Here, the risk and uncertainty. The energy mix should be robust enough to handle uncertainties in future. Resource availability, technological advancements, and policy changes. Sensitivity analysis can assess how changes input assumptions, example fuel prices or policy shifts, and affect the optimal allocation. So fossil fuels have been primary source basically of energy for many years, but they come with several issues as they have limited supply, which are existable and cannot be reused. They also cause a pollution, lead to global threats like global warming. Therefore, the global trend is to shift the generation towards a clean energy and sustainable energy. With the growing advancement and popularity of a PV based or solar cell, and PV based systems are extensively used in various applications. With increasing penetration of power electronic devices and nonlinear loads, harmonics are introduced into the systems. So the main problem in planning for optimal operation of the renewable energy sources and it to be operated with the battery storage system is the so the battery storage systems, that amount of data must be considered to cover an entire observation. If the observation period is 1 year, or characteristic days, or average data daily or weekly, monthly data are to be considered to reduce the number of data. So these are the improvements in renewable energy sources by US, where the US is 10.3%, wind hydro is 6%, solar 3.4%, biomass is 1.2 and geothermal is 0.4%. So the US electricity renewable energy generates over 20% of the for entire their production. In 2022, it is a data. The annual US renewable energy generation surpassed a coal for first time in history. By 2025, domestic solar energy generation is expected to increase 75% and wind by 11%. So the United States is a resource-rich country with enough renewable energy resources to generate more than 100 times the amount of electricity Americans can each year. And now I will share few facts about our power grid network of India, where we are in renewable energy resources. The India surfaces a 200 gigawatts mark in renewable energy capacity. Now, it is a recent data collected from the Power Grid Corporation of India with the help of internet only. So, as of October 10th, the renewable energy generation in India is 201.45 gigawatts. So, India has reached a significant milestone in its renewable energy journey, with the country's total renewable energy capacity crossing the 200 gigawatts mark of October 10, 2024. So, according to the Central Electricity Authority, the total renewable energy based electricity generation capacity now stands at 201.45 gigawatts. So, this achievement is the India's growing commitment towards a clean energy and its progress to build a greener energy for future. And it is the milestone reflects a results of years dedicated efforts to harness of India's natural resources. When the total non-fossil fuel based power now accounts for almost half of the country's installed electricity generation capacity. As we know, few thermal power plants are not working and few thermal plants are at shutdown stage. So it is the energy shared by the various renewable plants. And hydro is around 46.92 gigawatts. Wind is 23%, and small hydro is a 2.5%, and bio 5.6, and whereas solar is 45. So by year, if we go with the from last 5 to 10 years data, and year by year, the energy produced by the solar and wind is increasing. So India's total electricity generation capacity has reached 452. Among this one, around 201% is by renewables. So accounting for 46% country's total installed capacity now with the renewable energy source, which marks a major shift in India's energy landscape, reflecting the country's growing reliance on clear, non-fossil fuel-based energy sources. The variety of renewable energy resources contribute to this impressive. Solar power leads the way with 90.76 gigawatts, playing a crucial role in India's efforts, whereas wind is 47%. And the other ones, biopower, which includes biomass as well as biogas energy, adds a 11% to the renewable energy. These bioenergy projects are vital for utilizing agriculture waste and other organic materials to generate power. Further diversifying India's clean energy sources, togetherly, these renewable resources are helping the country reduce its dependence on traditional energy sources, which are fossil fuels, while driving a progress toward a more sustainable and resilient energy for future. So it is a renewable energy capacity installed in, these are the top 3 states in India. The top one is Rajasthan with 30 gigawatts, 29.98, and next Gujarat is more, 29.52, and Tamil Nadu is there, 23.7, and fourth one place is Karnataka, 22.37 gigawatts installed capacity is there already. It is the working generation with the renewable energy capacity, energy sources. So, in my conclusion, so India's renewable energy journey has reached so significant stage. That means up to 43%. Here, the central government of India given a few policies. Nation's commitment to a sustainable energy for future, driven by a diverse array of renewable sources, which includes a solar, wind, hydro, and bioenergy. The proactive initiatives such as the National Green Hydrogen Mission and PM Kusum and PM Suryagar and the PLA schemes. PLA schemes are the to manufacture the solar PV modules. So the government strategic focus on enhancing energy generation capacity while reducing fossil fuels with
Sir, voice Scotland, sir.
So these efforts reflect the commitment to fostering the sustainable energy for future while addressing the challenges posed by the climate change as well as energy security. So these are the few green hydrogen mission, PM Kusum, energy power bids for 50 gigawatts for annum for renewable energy. So project development cell has been established to attract the investments in the renewable sector. To plan energy assessments, to provide the facilities, and to plan this allocation of renewable energy sources together and to commonly operate. There are standard bidding guidelines issued for the tariff-based competitive bidding for procurement of a power from grid-connected solar, wind, and wind solar projects. And ultra-mega renewable energy parks are being set up to provide land and transmission for large-scale renewable energy projects. Here, the cabinet approved for a viability of a gap fund wind energy projects and facilitating installed and commissioning of a 1 gigawatt offshore wind energy capacity along the coasts of Gujarat and Tamil Nadu. So issued electricity right of consumers rules for net metering up to 500 kilowatts or electrical sanctioned load, whichever is lower. Policy for wind power projects, it is released. The strategy of establishment of offshore wind energy projects outlines bidding trajectory of 37 gigawatts by 2030. So it's my conclusion. So we to be power our electricity to be green tomorrow. So we need to powering a country for a greener tomorrow. Hello, sir. Sir, are you there? Hello.
Yes, sir. Yes, sir.
Sir?
Yes, sir.
Sir, okay, sir. That's why you record.
Okay.
Sir, is continue.
Sir, stop the screen. That's why.
Okay.
Thank you, sir. Thank you for valuable presentations. Now, Dr. Devasaran sir is going to be a present the vote of thanks. I am giving this session to the Dr. Devasaran.
Good evening, everyone. I'm Dr. R. Devasharan, Professor, Electrical and Electronics Engineering Department, Holy Mary Institute of Technology and Science, proposing vote of thanks on this day. It is my privilege and honor to deliver the vote of thanks for this enlightening FTP program on optimal allocation of energy sources in renewable energy scenario. So, sir, I would like to thank you for delivering lecture on this topic. And on behalf of Holy Mary Institute of Technology and Science Electrical Department, once again, I extend my grateful to you on this day. Thank you very much, sir, for kindly delivering the lecture on this topic. And we are so grateful to you. Thank you very much.
Okay. Thank you, sir.
Thank you, sir. Thank you very much, sir.
Yeah.
From participant side, this is your time, any question? Sure, okay. Thank you. Thanks to one
Okay,
and
sir.
all.
Thank you.
Okay, thank you.
Next session, it will be in 3:30.
Okay. Participant, please log out now and join the session again, 3:30.
We will send the next Google link.
Okay, sir. Thank you.
Thank you all.
Thank you.